Hello everyone, this is Ari from Pantech. So in this previous session, we have came to the concept of we have to develop the code for watchdog timer, right? So why we have configured this means to check our microcontroller at the routine of time. So this will watchdog timer will check our controller at the regular time. So that's why we have configured this watchdog timer. So what today we are going to do is we have already configured this we have already connected all the sensors with this STM32 and we have finished all these setups. So we have started this pumps, all these finished the functions what is the STM32 has to do. So what is the one thing is left is we have to transfer those sensor data to the LoRa receiver which is connected to ESP32, and we are going to send these sensor data sensor data and pump states and sprinkler states. So what is the state of it? It is tuned on or off. So these are data we have to send to ESP32. Why we are sending to ESP32? Because we are going to interface with ESP32 with the cloud. So we can see this temperature readings and we can operate this control this controllers by using this cloud or by PC or smartphone user interface. Okay. So we will get into this and we will develop the codes for both ESP32 and as well as STM32. So STM32 is going to be act as an sender and ESP32 is receiver. Okay. So today we will get into this concept. So before that, now we will see what are the steps we have to do for sending and receiving the data. Okay. So for when we take STM32, we have to initialize this LoRa first, and we are going to create this transmit function. So we are going to create a new transmit function to send this sensor data. Okay. Then also it is going to send this pump and sprinkler status. Then when we come with the ESP32, we have to initialize this LoRa. Then we are going to create a new function called separator function. So I will comment with later. So why we are creating this separator function means, so our LoRa STM32 LoRa sender is going to send the data in a serial way, right? So we have to separate those data. So we have to separate the temperature data, humidity data, and we have to identify those data, and we have to store it in the variable which is to the desired value. Okay. So that's why we are going to create this separator function. So we will see in the code. Okay. Then we will store this values in the desired variables. Okay. So temperature means it is going to get stored in temperature like that. Okay. So now we will get into the code and develop the code. So already we have created this. This is a program which we have created yesterday for watchdog time, right? So I will write. So what are the things first we have to do is we will take this timer out, sorry, temperature out, and I'm going to initialize this timer after the load. Okay. And STTL. And I'm going to tune on my LED after initialization of my load. Okay. So this is we have already initialized in the LoRa session. So we will make it reinitialize. Okay. Okay. So what is the next thing we are going to do is we have to need this LoRa. Okay. So now we have configured this LoRa. So this is how to configure this LoRa. We have already seen this in the LoRa session. So if you want to refer those things, which you can refer to those videos. Okay. So we will take out this. So what is the first thing we are going to create is we are going to create a function. Okay. So we have to create this. There is a LoRa state as LoRa start. Okay. So what are the next things we are going to add here is we are going to add these static of pump state. We have to say the pump state, right? So we are going to add those things. So you went of 8 of T. So in this, we are going to say the pump state. So of state. Okay. So I will make it as initially 0. So next we have to configure this sprinkler state, right? Okay. Sprinkler state. So what is the next thing we are going to do is we are going to create a function for LoRa transmit, right? So for that we are going to create this static of void. In this I will send these things. LoRa transmit. You make it as LoRa transmit. So now we are going to create a function for it. So we will create this function. So what are the things we have to do inside this? So what is the first thing is we are going to call this moisture and temperature function. So to know this moisture and temperature value. So what is our moisture, right? So we have this moisture here and as the temperature. We have temp as the temperature. So we are going to call these moisture and temp. Okay. Okay. So what is the next thing we are going to do is we are going to create a array. So which is a character of values. So we are going to send the values to this array only. Okay. So I will make a size of 21. So what is the next thing you have to do is we have to include this string functions as include of stdio.h. Okay. So in this we will have this sprint of f. Sprint of f. In this we have to first give our value. We have to call this array values array. So then next what are the values we have to set? So it is a sprint function is like a normal function, the printf function in the C. So when it comes to the embedded C, we are going to send these sensors values. That's all. So what we are going to do? We have to send the 5 values, right? So what are the values? Moisture percentage value, temperature value, humidity, pump state, and sprinkler state, right? So for that we have to say what is the data type it is. It is a float, integer, or a character. So first 3 values moisture, temperature, and humidity is going to be in the float. Then my pump state and sprinkler state will be in the integer, right? So we will do this. We have to mention the type. So 2f. This will say this is for 2f. So this is it is for float. Okay. So we have to make these things again. 2f percentage of. Then what is our rest two values is it is pump state and sprinkler state. So it will be in the integer, right? So percentage of d. Okay, we have to close this up. So then we have to call these functions: moisture percentage, temperature, then humidity, and pump state and sprinkler state. Sprinkler state status. Okay. So we are going to call these things. Now I will use this LoRa transmit function. LoRa transmit. You have to say the LoRa, my LoRa of it, and you have to call these values array. Okay. Then we have to say this size. It will be 22. Then my timeout is 500 milliseconds. Okay. So this is a function we have to create first. Oh. Now we have created these functions, right? So we will compile this. Okay, that is not. So before this, we have to. So the loop is going to get inside this pump function. So we have to call this LoRa transfer in the pump function. So we will go into this pump. Before this, we are going to give this all of delay of 50 microseconds. 50 milliseconds. Okay. Okay. So now we will get into this pump function. So in this pump function, first I have to transfer here. So I will call this LoRa of trans. Okay, I'm going to transmit the data here once. Then I'm going to transmit. We're going to transmit inside all the loops and outside all the loops. Okay. So if my loop reaches this position means what is my pump state? So my pump state will be tuned off. So that means we have to say the pump state is 0, right? So now we are going to give this pump state here. So right. Pump state is equal to 0. Okay. Then we will transfer again. So what here we have to do is it is a sprinkler, right? So sprinkler state is equal to 0. Then we will again transfer this function. Transfer this sprinkler is equal to 0. Now we have to give here a pump state. This is a pump, right? So pump state is equal to when it comes this into inside this loop means what my pump state will be. It is 1 because it is tuned on, right? So then I will transfer this function. Then when it comes with this means we have to give this sprinkler, call this sprinkler function. Sprinkler state is equal to 1, right? Because when it comes to this loop, it is going to tune on my sprinkler. So this is a function. Then we will transfer. Okay, we have transferred it already. This and paste it here. Okay. So now we have finished these setups. Okay. So now we will call these functions. So if we declare it in static, yes, we have static declared. So now we will compile this and call this LoRa function. Okay. So before getting into this uploading this code, we have to create this code for Arduino, right? So we will get into this Arduino ID. Okay. So we have already configured this Arduino in the previous classes. Sorry, ESP32 in the previous classes for receiving the data. So we have already developed the code for receiving the data, right? So I will make the code copy here. So if this LoRa is available, we are going to read the data, right? So for that, we are going to use this serial of print. Okay. So in this new line, I'm going to get this character of. Wait a second, guys. So LoRa dot of read string, right? Okay. So this is the function we are going to call. Then it is going to, we are going to give this delay for milliseconds. Okay. Then we have to print this RSSI. Okay, so we are going to print this RSSI. So which portion it is getting stored? So serial of print. And this inside this I'm going to, so we have this function. We will call those function for a packet. Okay. Now we have completed this code, right? So what next thing we are going to do is we will change this delay here. Okay. So we will upload this code in our ESP32 and we will see some of this. Okay. So now you can see, wait, we will upload this code and code has been uploaded. Okay. So reset this and so we are going to change this code. So what we are going to change here is we will get this in some this variable. Okay. So we are going to store this value in this variable of RCV. So RCV is equal to LoRa dot read string. Okay, I'm going to read those strings and I have to print those values, right? So serial of print. So print of. So in this, I'm going to give this RCV and I will print this RSSI with this packet. Okay. So now we will upload this code. So it is compiling. Right. So we have already uploaded this STM32 code. So which is going to send our first moisture percentage, second is our temperature, third is humidity and pump state and sprinkler state. So when you can see, when this we will take an example of this loop. Okay, this place. Okay. So if this code is come and say this loop means it will reach this moisture sensor and temperature sensor and updates the value in the moisture percentage and temperature variable. Then the LoRa will transfer those data to the ESP32 and the washout timer will be refreshed. Next, this pin will be get or motor pump will be get tuned on. Then after this motor is tuned on, then the pump will be get into our state. So we are giving this pump state is equal to 1. So it is going to set this logic 1 in the pump state variable. Then inside this LoRa transmit function, we will read this pump state variable. So it will be as it will be having a value of 1, right? Then it will sense this pump state as a 1. So likewise for this also you can see. So the sprinkler state is equal to 1. We are initialized as a 1 when this loop is tuned on, when the sprinkler motor is tuned on. This will be get read by inside this function LoRa transfer. Inside this it will call this variable sprinkler state. So what is our sprinkler state? It is 1. So 1 means it is tuned on. Then it will transfer the file. So this is how the files are. This is how the state of the pump is shown. Okay. So now we have compiled this and see the. So you can see we are using the packages from the STM32. So you can see first is our moisture value, which is 41.74. Next is our temperature value, it is 27.2. Next is our humidity, which is 62.00, and we have this pump state and sprinkler state. It is both the states, both the pumps are tuned off, so it is in the 0. Okay. Now I will remove this moisture sensor from water. Okay, I have dipped into inside the water. Now I will take it out of it. Okay. Wait. So the motor is now, the pump is tuned on, but now the sprinkler is not tuned on because the temperature is less than 30 degree. Sorry, temperature is 27 degree Celsius. So if the temperature exceeds this, sorry, wait a second. So now this sprinkler also tuned on. What is our condition? So it is more. If it is more than 24 means it is going to tune on this both the sprinkler pump also. So now you can see both the pumps are tuned on. So you can see we are getting 1 for these two things, and we are getting moisture percentage as 4.4 and temperature as 27. So it is more than greater than 24 temperature, right? Now we have to get this readings, right? So now we have to get this readings in the ESP32 and we have to store it in the desired variable, right? So for that we are going to create the code. So we will get into this thing. So I will. So now you can see our pump, both the pumps are tuned up. Okay, the moisture sensor is increased. So what is the next thing we are going to do is we are going to wait. So what is the next thing we are going to do is we are going to assign this moisture sensor percentage to a moisture variable. Likewise for temperature variable, pump state variables like this we have to assign it. So for this only we will create this separator function. So what is this separator function is going to do is so you can see my first value of moisture percentage is sent, then it will give us a colon. So this colon is going to act as a separator. If this ESP32 recognizes this colon means it is going to stop the process and it is going to start the process from the next variable. So if this moisture percentage is updated, if this moisture percentage is values come along with this end of the colon, if this colon is recognized, then it will jumps to the next variable and store the temperature value in the temperature variable. Like this, we are going to do this. So that's why we are using this separator. Okay. So now we will create this separator function. So go to this Arduino. So in this, what is the first thing we have to do is we are going to alter this. First, we will create this separator function. Okay. So we will create this here. First, we will make it a string. So in ESP32, in Kyle, we will not have this string as a data type, but in Arduino, we have this string. We can declare this as a string. So we are going to make it as get string. Okay, separator. So inside this, we are going to pass the 3 parameters. So string of data. Okay. Next is character of separator. Separator. Then is int of index. Okay. So inside this loop, we are going to first define this string data. So string of data, I'm going to declare this variable is equal to 0. Initially, I'm going to make it as 0. So what is the next thing I'm going to declare is string of data part. Okay. So it is going to be my data. So now we have declared these both the functions. What is the next thing we are going to do is we are going to create a loop. Okay. Okay. So what is the next thing I'm going to create is I'm going to create a for loop. So inside this I'm going to call this int of y is equal to 0. Then I'm going to call this function which is a data length. So if I call this variable, so variable name is data. So we are going to give this we are going to load this value in this data only, right? So we have to call this data name, and we have this inbuilt function of length. So this will find a data length. So we are going to minus it by 1. Then of I of plus plus. So what is the next thing we are going to do is we are going to check whether this it is reaching this separator. So we are going to create a function if it is data of I is equal to 7. Okay, separator. Then what do we have to do? Okay, so we are going to check that it is a separator. If it is if it reaches the separator, means what we have to do is we have to add this string data. Okay, so we will add this string data which is declared in the we have declared here. So you can see it. Okay, so we are going to add these things. So if it is not a separator, means we are going to create a else condition, else of if. So in this, what it is going to do is it is going to check with this index. If my string data is equal to index, okay. If it is a string of data equal to index, okay. So if it is equal to index, means what is our index will be, means it will be like what is the first value. So I want to capture this moisture percentage, means I have to give the index as 0, because the first value is sent by the STM32 as moisture percentage, right? So I have to give this index, okay. So if it is index, means we are going to call this data part function, which will be in the data part function in the STM. So we are going to call this concatenate. So which is going to join our data. So we know that concatenate function, which is going to join the two strings. So this function will do those things. If it is not equal to index, means we are going to create another else. If it is what we are going to check is we are going to check it is more than index. Okay, index data. If it is more than index, means we are going to perform a return data part. So we are going to return this data part value. Data. So which we have declared above in the starting of the. Then we will do a break function. Okay. So then what is the final step we have to do is we have to return this data path again. Okay. So this is a separator function. Now we have to call this function inside this loop, right? So we have to modify this loop function. Okay. So these are the same. So leave it as it is. Okay. So these. Okay. Now we have first we have to declare this RCV. Then we have to print those RCV values. Then we will check this packet of RSSI. Then I'm going to go with this print a new line. Serial dot ln of slash of n. So this will print a space between it. So what is the next thing we are going to do is we are going to normally we are going to call these functions. Okay. So string of first I will call this moisture. Okay. Because my first index is it is going to be a moisture percentage, right? So I'm going to call these functions strings. So inside this, I have to first give the data. So where is my data stored? It is stored in this RC, right? So I will give this. Then I have to say separator. So which is a symbol I am using for separator. Okay. So for that I am going to give this colon. So I am going to use this colon as a separator. So what is my index? It is 0, right? Because my first value of the STM is going to send this moisture percentage. So first moisture percentage is in the 0th index. So we will give this 0. Okay. So these are the things we have to do. So we will do it for rest of the values. So what is the next value? It is going to be it is going to be inputted in the ESP32. It is temperature, right? So TM, okay, I will get to TM in index of 1, then index 2, 3, and 4. So in index 2, it is going to, we are going to receive this humidity value, HUMI. Then in this pump state, so like this pump. And here we are going to get this sprinklers. Okay. So we are going to get this sprinkler in there from the index 4. So what is the next thing we have to do is we have to see the output in serial print, right? We have to see the output in serial monitor, right? So for that, we will print these things. See. So inside this, I'm going to call this moisture. I will name it as moisture. So my moisture is going to be plus. So we are going to concatenate this. We are going to concatenate the character moisture and the moisture percentage. Okay. So now I am going to call this. So this is a step we have to do for. Okay. So next is temperature. So it will be in the variable of temp. So next is humidity, right? Next is pump state. Pump state. So pump state will be in the pump variable. Okay. Next sprinklers. Sprinkler. So this is sprinkler state. Okay. So now we have defined these variables. So where we have to store these values. So what is the final step I'm going to do is I'm going to give a slash of here. So now we have completed this code. Just we have to create this. Okay. Now we will compile this and we will see whether we have code errors. Okay, error in codes. So we have no errors. Now we will upload these things. Okay. Now we have upload this code. Okay. So we will get into this. So you can see first we are receiving our all the values in the string. Then the adding this code is separating these values and storing it in the desired variables. So moisture value is 40%, and the temperature is 26, humidity is 59, and the pump state is 0, and the sprinkler state also 0. Now I will remove this from the water, moisture sensor from the water. So now you can see the moisture sensor is reduced. Now the pump state 1 is pump state is showing as 1 because my first pump is tuned down. Next the temperature is more than 24, so my sprinkler also tuned. So you can see it is showing a state as 1. So now we will again repeat, and if the moisture is increased, if my moisture sensor percentage is increased means you can see now our pumps is stopped. So this is how we will transfer the data from STM32 to STM32 ESP32. Without the wired communication, this communication is happened in the wireless using the LoRa module, right? So what is the final thing we have to do? Just we have to configure this. We have to configure the ESP32. We have to connect this ESP32 with the cloud. So guys, we will connect this ESP32 with the cloud in the next session. So today's session is over, guys. I will meet you on next session. So thank you, guys.